All right, so here's a couple integral practices, okay? All right, so if you're given the velocity function, okay, you have to take the integral to get to position and the derivative to get to acceleration, right? Because it's always like this way, like in the stacks of curves, position, velocity, acceleration, you take the derivative this way, or the slope, and then the integral this way, okay? All right, so if I have VT negative 4 plus 6t, okay, the position function is going to be like one above that, all right? So if I take the integral, see this has basically an implied t to the 0 now, right? So then that's going to be a t to the 1, okay? Or just, we usually would just say t, right? We wouldn't say t to the 1, okay? And then plus 6t, all right? So when I took the derivative, it needed to turn into 6t, and I know that this is going to be a t squared, right? Because it's going to be one exponent up. So this would have to be a 3, right? So when I move this 2 to the front, that's how I got the 6, okay? And then in theory, you'd have this plus x naught, but right now we don't really care. We'll just say it's 0, all right? And then taking the acceleration, oops, we're just going to take the derivative. Okay, so we get rid of that. Okay, so the constant just goes away. 6t is just going to be a derivative of 6, okay? Which means this is going to be a constant acceleration because the position function is a squared, okay? All right, what would the initial velocity be? All right, remember initial velocity just means when the time is 0, that's it. Okay, so if I just basically plug in a 0, then this is going to be negative 4 meters per second, all right? And then what is the object's position when the velocity is 32 meters, okay? So this one's a touch trickier because we don't really know the time. So the first thing you have to do is find the time. Okay, so at what time, plus 6t, is the velocity going to be 32? All right, move the 4 over, 6t is 36. So the time is going to be 6 seconds where this happens. All right, and then all you have to do is just plug it into your position equation, negative 4t plus 3t squared. Remember, we're just not going to bother with the constant. So negative 4 times 6 plus 3 times 36, it will be 84 meters. Okay, all right. All right, one more. A particle accelerates following the function negative 8t plus 3. Right, so this is going to be a non-constant acceleration because it's time dependent here, okay? Otherwise, it would just be a number, right? So on my acceleration graph, this is going to be some kind of a line. Well, actually, it'd be this way because it's negative, right? Okay, it's going to be some kind of a line on my acceleration graph, a diagonal line, as opposed to a horizontal line when it's constant acceleration, okay? All right, so then I want to go ahead and integrate, right? Because acceleration is kind of like, I usually think of it like the bottom graph, okay? So I want to go back. So this is going to be negative 8t plus 3, all right? So when I go this way, I know that's going to be a t squared because I have to go up an exponent, okay? This is t to the 0, right? So that's going to be a t. And then I just have to figure out what this number should be in front here, okay? So if I move the 2 down, right, then that's going to have to be a negative 4, right? Because when I move the 2 down, that would be negative 8. Okay, do it one more time. So now I know that this term is going to be a t to the 3rd. All right, so that 3 would come to the bottom, so I'm going to have to put a 3 on the bottom like that, which would cancel it. All right, plus that one's going to turn to a t squared. Okay, and again, that's going to be 3/2, right? Because when that 2 comes down, it's going to, cancel and then leave me with a 3. Okay, and then we'd have probably plus some constant, which we'd have to find, but probably we'll assume it's 0. All right, and that is that.